All right, this video is for 3.4 solving logarithms. This is our second day. So we're solving logarithmic equations. We've already solved some exponential equations. So when we're doing this, the first thing that we want to look for is what's happening on both sides of my equation. On this first equation, I have log 15 with this stuff inside the log, and then I have the equal sign, and then I have log 15 again on this side, and then I have this negative a inside the log. But because both sides of the equation are equal except for what's inside of each log, right? In order for log base 15 of this stuff to equal log base 15 of this stuff, in order for that to be true, this stuff would have to equal this stuff. So really the logs here I can just drop because there's one on each side. There's nothing else going on outside of the log, and they're both base 15. Because of that, I can actually just kind of drop the logs and just solve the equation negative 2a minus 8 equals negative a. Okay, so sort of like when we were doing the exponents, we had the same base, then we could drop the bottom number and just set the exponents equal to each other. It's the same type of thing here. If I have the same log with the same base and nothing else going on outside of the log, I can just drop the logs and set this stuff inside equal. Now I want to go ahead and solve this equation for a, so I'm going to add 2a to both sides just to get those a's together on one side. So negative a plus 2a is just 1a, so negative 8 equals a, and that is our answer. One thing though on these log functions, we have to make sure that once I take this a that I just found and plug it back in to any of these, I need to make sure that I get a positive number in there. If I get a positive number in there, then that is a good solution. If I get a negative number inside the log, that means it's undefined, right? Because remember that if I have something that is like log base 2 of negative 8, like, and I want to solve that. Remember when we had this, we solved it by setting it equal to x. We changed forms, 2 to the x equals negative 8, and then we found that there's no number that I can raise 2 to in order to get negative 8. If I make x a positive 3, I would get 8, positive 8, and if I make it a negative 3, I would get 1 over 8. So this is undefined. So because of that, anytime I have a negative inside my log, the function is going to be undefined. So this was just kind of a side note to explain why we need to check this solution to make sure I get positive numbers inside both of my logs. If I don't get a positive number there, then I know that it's undefined. So if I plug in negative 8 for a here, I'm going to get negative 8, which is positive 8. So that one's fine. That one gives me a positive number inside my log. If I plug it in here, I'm going to get negative 2 times negative 8 minus 8, which is 16 minus 8, which is positive 8. So again, a positive number in both of my logs tells me that this is a good solution. Okay, on number 2, I have the same type of situation. I have a log base 16 on both sides. There's nothing else going on outside of the log, so I can just take what's inside this log and what's inside this log and set them equal. In order for these two sides of this equation to equal each other, this stuff would have to equal this stuff, right? For both of these to be log base 16 and to be equal, the stuff inside the log would have to equal each other. So 5n minus 5 equals n minus 10. I'm going to add n to both, subtract n from both sides. So 4n minus 5 equals negative 10. Add the 5 over. 4n equals negative 5 and divide by 4. So n equals negative 5/4. Let's go ahead and check our solution. If I plugged in negative 5/4 here, I would get 5 times negative 5 over 4 minus 5. This would give me negative 25/4 minus 5, and 4 goes into negative, or 24, negative 8 times, no, negative 6 times. So that gives me a negative inside my log, and because of that, this is not a good solution, and this is an undefined. So no solution on that one. Okay, again, because I took my solution, I plug it in and it gives me a negative inside the log. It can be any of the logs up there. Okay. All right, so number 3 looks a little bit different. I don't have a log base 3 on both sides. I have 2 log base 3's on this side being added together, and it's equaling a number on this side of the equation. So because of that, I need to change tactics a little bit here. The first thing I'm going to do if I have more than one log on one side of the equation is I'm going to condense the logs. Remember our properties of logs that we talked about last time? If I have a plus between 2 logs with the same base, I can condense those into one log, base 3. I would take the stuff inside this log and the stuff inside this log, and I would multiply them together. So that's going to give me x squared plus 24x, right? I'm just multiplying x times x plus 24. And if I carry that x through, that gives me x squared plus 24x. And then this is equal to 4. So I still don't have a log on each side, but now I have this left-hand side condensed into one log. Now that it's condensed into one log, I can change forms here. I can change this into exponential form. So remember, my little base here will be raised to the exponent of 4. So we're changing forms to exponential form. So 3 to the 4th power equals x squared plus 24x. Now 3 to the 4th power, let's just quickly see what that is equal to in my calculator. So 3 raised to the 4th is equal to 81. So I have 81 equals x squared plus 24x. Now this is a quadratic because my first x is squared and then I just have a regular x. So I need to solve this like a quadratic. So I can either factor it using x factoring, or I can use the quadratic formula. Either way, I need to get one side equal to 0 and get it in standard form. So I'm going to subtract the 81 from both sides to get this equal to 0. And then I'm going to x factor it. Again, you could also use the quadratic formula if you prefer that. A is 1 and C is negative 81. So if I multiply that together, I'm getting negative 81. B is 24. So I'm looking for two numbers that multiply to negative 81 and add to 24. So let's see. So that would just be 27 times 3. Because my 24 is positive, I would want to make the 3 negative. And then I can rewrite this as 0 equals x plus 27 times x minus 3. Don't forget when you're x factoring, you always want to take your numbers and divide them by a, but in this case, since a is 1, it won't change anything. So my two solutions here are going to be negative 27 and 3, right? If I set these each equal to 0 and solve for x, I'm going to get negative 27 and 3. So these are the solutions, but now again, I need to double check them to make sure I get positive numbers up here. But right away, since 27 is negative, I can see if I plugged it there, I'd get a negative inside my log. Same thing on this side, negative 27 plus 24 would be negative 3. So because I'm getting negatives inside my logs here, negative 27 I will not keep as a good solution, but 3 works great. So it just has one solution here, and it's 3. Okay, that was a lot of steps on that one. Not all of them will have that many, but let's go ahead and try this next one. So notice here, on this left-hand side, I have 2 log base 7s. On the right-hand side, I have 1. So I can't just drop the logs yet. I need to first condense this left-hand side so that it is in 1 log base 7. Once both sides just have 1 single log base 7, then I can drop the logs and set what's inside the logs equal to each other. So let's first condense this. Remember, if there's a minus between my logs, that means I'm going to be dividing the expressions. So when I condense this into 1 log, it's going to be log base 7 x minus 7 over 3 equals log base 7 of 28. Okay, so now we do have that single log with the same base on both sides, which means I can drop the logs and I can go ahead and just solve x minus 3 equals 28. Now, I want to caution you here, you can only drop those logs if you have 1 single log of the same base on each side. A lot of times when people get these type of questions, they get used to doing these, then they look back at something like number 3, where it's not equal to a log on the right-hand side. It's just equal to a number. So on that one, I can't drop logs. That one I have to change forms. So if there's not a single log of the same base on both sides, you're going to need to use a different method. You can't just drop the logs. Okay. So now I need to solve for this x. The first thing I'm going to undo is divided by 3. So I'm going to multiply both sides of this equation by 3. And that will cancel those on that side. So I'll be left with x minus 7 equals 28 times 3, which is equal to 84. Now I can just add 7 to both sides. So x is equal to 91. And then just double check, make sure if I put 91 up here in any of these expressions for x, this is the only one that has an x. So 91 minus 7 is definitely a positive number, so this is a good solution. So that would work out just fine. Okay, so let's just try a couple more here. So on number 5, we have 2 logs on the left-hand side. We have no log on the right-hand side. So this is one of the ones where we're going to have to change forms. But before we change forms, we need to condense the logs on the left-hand side. I've got a minus between here, which means I'll have x minus 6 over x. Okay, x minus 6 over x equals 2. And now I can change forms. So the base would be 5, and the exponent would be 2. So 5 squared equals x minus 6 over x. Okay, which simplifies to 25 equals x minus 6 over x, just squaring the 5 there. Now I need to get x out of the denominator, so I'm going to start by multiplying both sides of the function by x. I'm just undoing divided by x there, which gets rid of those. So then I am left with 25x equals x minus 6. Subtract an x from both sides, 24x equals negative 6, and then divide by 24. So 6 over 24, that reduces to negative 1 over 4. So negative 1/4, let's plug it in to check. If I have negative 1/4 and I subtract 6 from it, that gives me a negative inside my log. Likewise, if I just plug in negative 1/4 for x, another negative inside my log. So this one would have no solution. I can't keep that solution because it gives me a negative inside my log, which is undefined, right? All right, let's see. Let's do number 6. I don't want to do every one of these, but we'll do a few more. So on number 6, we're going to have to condense the left-hand side so you have more than one log. It's a minus again, so if it were a plus, I'd multiply. If it's minus, I divide. X plus 6 by 8 equals log base 9, 19. So again, we have a log base 9 on both sides, which means I can cross them out. But be careful, watch that. If this one doesn't have a log on it, I can't just set this equal to this, right? Only if they both have a log of the same base. So x plus 6 over 8 equals 19. Let's multiply both sides by 8, so that will cancel, which gives me x plus 6 equals 19 times 8, which is 152. I'm going to subtract 6 from both sides, so x equals 146. Okay, so positive 146, if I plug that in here, that's going to give me a positive number. So x equals 146 is a great solution, so go ahead and keep it. Okay. All right, let's do 1 or 2 more. Let me just look at what I've got here and see what would be best. Okay, we'll do 2 more. We'll do number 7 and then we'll do number 10. So on number 7, we have 2 log base 5s on the same side. We have no log over here. So we're going to start by condensing these. I have, again, a minus between, so I'm going to divide. So 5x squared over 9 equals 5. Now I'm changing forms, so 5 to the 5th power equals 5x squared over 9. So 5 to the 5th power, that's going to be a pretty big number. So 5 to the 5th is 3125. And that's going to be equal to 5x squared over 9. So now I can go ahead and get rid of divide by 9 by multiplying both sides by 9. So 3125 times 9 is equal to 28,125. That's equal to 5x squared. We'll divide each of those by 5 to get rid of that. So if I divide that by 5, it gives me 5625. And then I need to take the square root of both sides to get rid of x squared. And remember, whenever I take the square root of an x squared, I will get a positive and negative solution. So the square root of 5625 is equal to 75. Okay, so two solutions, one is positive 75 and one is negative 75. If I look back up at my equation, if I were to plug in positive 75, I'm definitely getting a positive in here. 5 times positive 75 squared is positive. If I plug in the negative 75 squared becomes negative 75 times negative 75, so that one also comes out positive. So because these both give me a positive inside my log, I can keep both solutions. So there's two solutions. One's positive 75 and one is negative 75. Okay, so let's try number 10. So again, two logs on the left-hand side, no log on the right-hand side. So we need to condense and then change forms. So log base 9, this one has a plus between it, so we need to multiply. So 2 times 3x is 6x, and 2 times 8 is 16, and that's going to equal 1. So now that it's condensed, and I check, there's not a log on both sides, so in this one I have to change form. So 9 to the first power equals 6x plus 16. So 9 to the first power is just 9. We're going to subtract 16 from both sides, which gives me negative 7 equals 6x, and then divide by 6. So x is equal to negative 7 over 6. If I plug in negative 7 over 6, I need to check that carefully. So 3 times negative 7 over 6, I'm just going to hurry and throw it in my calculator. 3 times negative 7 over 6 is equal to negative 3.5. And because negative 3.5 is smaller than 8, this is going to give me a positive number. When I add 8 to negative 3.5, I'm going to get a positive number. So this is a good solution. It doesn't give me a negative inside. Okay. So if you have questions, let me know. These can be kind of hard to get used to, but just make sure you're really checking to see if there's a log on both sides. And remember, when there's an x squared in there, that is going to give you a quadratic, which if it's a quadratic like this where there's just an x squared and there's not an x, you're okay just to take the square root. But if there is in your equation an x squared and an x, like there was in the one above, like on number 3, if there's an x squared and an x in your equation, then you need to solve by either x factoring or quadratic formula. Okay. Anyway, have a great day, guys.